Let us look at proposition number 11 of works of Archimedes, specifically from on conoids and spheroids. Here there are 4 parts to the proposition. Let's take it one by one. We are given a paraboloid of revolution. Let its axis be A. Now, if we cut it by a plane parallel to this axis through A, then the intersection between the cutting plane and the paraboloid is a parabola. So let's first of all cut it by a plane, and now let's take the intersection between this cutting plane and the paraboloid. So this is our intersection between the purple plane and the paraboloid. Now the parabola of intersection is the generator of the paraboloid. So let me show you. So as you can see, this intersection is the generator of this paraboloid. Now the axis of the parabola is the intersection between this cutting plane and the plane through the axis perpendicular to the cutting plane. So which is this plane. So the bluish plane is perpendicular to this purple plane and it passes through the axis. So the intersection between these two planes is the axis of the parabola. That is a generator of this paraboloid. If the cutting plane is perpendicular to the axis, the intersection would be a circle. Now, if I have a plane perpendicular to the axis of the intersection, that is this green plane, then the intersection between this green plane and the paraboloid is going to be a circle. So that is what this part of the proposition says. Now let us look at the second part of the proposition. Given a hyperboloid of revolution, let its axis be A. Let a plane cut H through the axis or parallel to the axis or through the center. Now, when we say parallel to the axis, it will not be passing through the center. But when we say through the axis, it would be passing through the center. So here in the third point, it is the case where we are talking of the cutting plane is at an angle to the axis A, passing through the center. So the center is A. Now the intersection between the cutting plane, so let's bring in the cutting plane, and the hyperboloid is a hyperbola. So the intersection is a hyperbola. In case of one, when the cutting plane passes through the axis of the hyperboloid, the intersection, that is the hyperbola, is equal to the generator of the hyperboloid. In the second case, when it is parallel to the axis, the hyperbola is similar to the generator. And in the third case, the cutting plane is at an angle. The intersection, that is the hyperbola, is not similar to the generator of the hyperboloid. Now, if the cutting plane is perpendicular to the axis, the intersection of this plane with the hyperboloid is a circle whose center is on the axis. So if I take this cutting plane anywhere through the axis, the intersection would always be a circle. That is the second part of the proposition. Now the third part of the proposition says, given a spheroid, if we cut it by a plane, we'll cut it either through the axis or parallel to the axis. So let's cut it by, as of now, it is cutting it through the axis. Now, if it is parallel to the axis, it could be anywhere else other than through the axis. Then the intersection between the cutting plane and the spheroid would be an ellipse. So the intersection would be this, and this is an ellipse. Now, remember, a spheroid has major axis, minor axis. So here we were looking at it from one axis point of view. Now, if we have the cutting plane through another axis, then also if we look at the intersection, it would again be an ellipse. And the axis of the ellipse would be the intersection between the cutting plane and the plane perpendicular to the cutting plane. And finally, if paraboloid or hyperboloid or spheroid is cut by a plane through the axis, and if a perpendicular line be drawn to the plane of intersection from any point on the surface of the figure, but not on the intersection, then the perpendicular will fall inside the intersection. What this means is that if we take a point on the surface of the spheroid and we drop a perpendicular from that point to the plane of the intersection between the cutting plane and the spheroid, then that point, that is C, will fall inside the intersection. Doesn't matter where I take it. Similarly, here also. The only thing is, it should not be on the intersection itself. It can be anywhere else. So that is what this means. So that was proposition number 11 of works of Archimedes, specifically from on conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.